Well, hi, and thanks for joining me in my shop here. We're going to continue with this PYE multiband shortwave radio. One of my favorite radios, this one I own. So I had it for a long time, and just to update you on where I'm at, I was just bringing it in just to check it over and tune it up. I was going to do a real good tune-up on it. And I got partway through the tune-up, and I decided the output of the radio was driving me nuts. So the output was very, very low. So I decided I would investigate the problem with the output. And I checked out the output tube, voltages, all that kind of stuff. When I moved to the next tube in line, that would be the probably just an AF amplifier just before the output tube, I discovered I had the wrong tube in the radio. That's the sound of me slapping my head. Oh my gosh, how did I ever do that? And I admitted some embarrassment of discovering that I myself had put the wrong tube into my own radio. But the embarrassment doesn't stop there. Let's go further with the embarrassment. So in looking at all the information I have for this radio, I determined I needed to pick up a 6BQ7. You know, it's a good thing I have a lot of self-doubts about what I'm doing, because if I'd got a 6BQ7, if I'd actually gotten my hands on one, and I suspect it's not the right tube, it doesn't look like the right tube at all, I would have put another wrong tube into this radio, because it's not a 6BQ7, and if I only stopped and thought just a little harder, I would have realized it's a 6SQ7. That's really what I need. A 6SQ7 is a very common tube, and voila, I have a couple. Here they are. Okay, so these are good tubes. I tested them. We're going to put it in, and we're going to see what happens on this radio. Now I got better hook up a speaker here, or not much will happen. So I'll just use clip leads again. Where would I be if there weren't clip leads? Oh my gosh. They are so valuable. Sometimes, you know, the simplest thing, I mean, in terms of electronic things, a clip lead is pretty much at the bottom of the barrel, isn't it? But man, I use them a lot. I'm not sure I'm clipping the wire here. I use a little technique here to try to reduce the chances of a short occurring by clipping the wire like that. It keeps the clip leads apart. Except sometimes you don't quite get the conductors onto the clip lead itself. That looks good. Okay. And our speaker connections are here. Okie dokie. Now, we need to hook up the, we'll eventually need the signal generator. I'm assuming when I plug this tube in, everything's going to work. We'll need the signal generator, so I might as well connect this up to the antenna right now. So, here's this nice long one here. And that's the antenna back there. Okay. Excuse me. And I should probably attach the ground. So this will be the ground connection. And we'll just clip that onto the chassis there. Maybe over here where it's a little more out of the way. So there we are. And my wire is all hooked up here. Yeah, I should push one of these tubes in, shouldn't I? Okay, let's put it in. Ooh. Just 1 second here. Hold on. Another mistake I can make is have the right tubes but in the wrong place. Where's the tube? Here it is, here. Right down here. So V4, 6SQ7 V4, right beside the output tube in the transformer. That's right. That's where there's a tube missing. I did check the rest of the tubes, they are correct. Okay, I think we're in good shape here to give this guy a test now. I better turn on my signal generator here. Get it ready for action. Okay, just pausing to think hard here. Everything looks safe. Speaker wires, antenna wire. Nothing funny looking. We're good to go. Volume down because I'm expecting a big improvement in the volume here. And we'll put the power on restrictive at first. There we are. Nothing terrible happening, that's good. See the lights have come on the front of the radio here. A little cool in my shop. We'll give it a moment to warm up slowly. Probably foolish to even worry about it, but okay, we'll go on full power. Full power, full power. Now we will turn up the volume. Well, that's not very good, is it? Okay. I heard almost those exact same sounds with the other tube in here. I also noticed that when I turn the volume up, it's only when I get right to the top again that there's any volume, any appreciable volume coming out of it. Wow, this is really not the result I expected at all. Hey, that means there's fun coming. Man, nothing worse than when things work. Yeah, there's nothing to do if it all works. On a more serious side, wow, I'm really disappointed. So the fact that I'm hearing this sound with the correct tube in place and heard it with the wrong tube there pretty much says it's nothing to do with the tube itself. Yeah, some other problems with this radio. Some other problems with this radio. Well, I've been suspicious of these capacitors here just because they're molded. They look okay though. Right in the area of the volume. Now, didn't I have a whole bunch of confusion around how this was wired? And it seemed to me it wasn't wired right. Well, let's see if the radio is receiving at all. So they're just turned up full. It sure does sound like a radio to me. What frequency are we on, supposedly? Around 8. So I think I've left this pretty much the way it was, so we should be right around here somewhere. He says, hopefully. So what I'm doing is I'm tuning my signal generator. There's the numbers. And I'm just hunting. I'm hunting but not finding. Okay. I gotta figure out what band we're on here. Because I may have turned the radio band switch, you can't remember. Please turn the volume down. Okay, so that's the broadcast band. First band over, that would be the 49 meter band, I'm pretty sure. So I should be down around 6 megahertz. 6 megahertz. There's the signal generator. Let's take it down to around 6. Well, you can hear that thumping sound. Now watch my hand up there and listen. There it is there. Sounds like it's an unmodulated carrier. There we are. Modulation about 30%. Volume is full. Man, that's weak. So, well, man, that's really disappointing because the radio's working the same with the right tube as it was with the wrong tube. How can this possibly be? Oh my God, my head's coming off here. Why all these mysteries all the time? Well, really, could I have another tube in the wrong spot, for crying out loud? Of course not, it's me. In that case, I better check them very carefully. So, the RF amplifier, 6SK7. Absolute positive check of this. As stupid as I feel doing it. Six SK7. Okay, no doubt about that. That would be a 6 SK7. Managed to get the right tube there. Sounds a little clearer, doesn't it? V2 6K8. That'd be pretty important. So V2 is at the back. I'm quite certain that's a 6K8. It has a grid cap on the top of it. Hello, 2. 6K8. Okay. Hello, where'd the radio go? Just went quiet there as I... Why would it do that? Oh. Bad connection from my signal generator. Next one. Output tube, 6V6. No, there's another 6 SK7. Let's make sure of that one. And that would be V3. V3. V1, V2, V4, V5, V6. Why are they not showing V3 in there? That's kind of unusual, eh? Yeah, that's really strange. Hey, look at that, just faded out again. What caused that? See, not so lucky this time. Wow. Not only in a bad way, I'm in a worse way now. How did that happen? Well, I guess we know the answer to that question. The switch is a little unreliable. Band switch. Back to finding V3. There's a hidden vacuum tube in this radio. Well, no use staring at this diagram. It is not showing up on there. I have looked at every marking. So it's right in between these two cans, and this shows a T1 seat. You know, they just didn't put it on here. Isn't that something, eh? I'm sure it was an oversight. Okay, so it has to be correct anyway. It's a 6SK. Now the output, 6V6. Oh my god, could I possibly have that wrong? No. 6V6. 6V6. And lastly, the rectifier tube. Rectifier tube. It's calling for a 5Y3. I don't think that's a 5Y3 there. What is it? (5Y3). Okay, 5Y3, no problem. Okay, hey, we made sure we got the right tubes. Now we can get on with why is it doing what it's doing, or why is it not doing what it should do? Painter all the time. Well, let's check the voltages on the tube I just replaced. Because if I remember right, the other tube had bad voltages, and my assumption was somehow the wrong tube in the socket was responsible for that. That's a big assumption. It's not a good assumption at all, in fact. So the tube I'm after... Oh, wasn't that interesting? Just heard some, like a refrigerator come on in my house, and the radio's response was to make that whump whump sound. It probably has the supply voltage dropped. Hey, let's drop it now. See if it goes whump whump whump. No different. No difference. Okay, so let's check B+. I think I'm going to clip my ground lead here. Too many things in my hand at once. Or clip the negative lead of the voltmeter, rather. We're on the 200 volt scale. And the tube we're going after, that one right there. We'll start with pin number 1. It's very hard to see where the little key is on the tube. I think it's back there. So put my hand right in front of the meter. That's not going to work well for you or for me. Let's find some voltage here. There we are. Over 200 volts on that pin, so we know our meter's working. Back to where we were. I think that's pin 2. Looks like it's joined to pin 1. Oh, that's interesting. 3. Probably a grid. 4. 4 is grounded. 5 knocks the sound out. There's probably the grid. Knocks the sound out on 6 also. There's 7. What's 7? A screen? And 8. Yeah, no B+ on that too. That's what I say. That's probably the essence of the whole problem here. So let's track down why that would be. Why would you not have any B+ on you? So here's the tube here. And of course it's not telling us which pin's which. Thank you very much. So we'll have to get out the tube manual to do this. 6 SQ7. That'll give me a chance to see if the base or the pin layout matches what's on the circuit diagram in terms of what's inside this tube. Just a quadruple check. I really got the right tube in there. 6SQ7. Twin diode high mu. Yes, that's definitely it. I can see because it's got this cathode with two little plates beside it, and then a triode actually going on in there. That's exactly what's on the circuit diagram. Combined detector amplifier AVC. Oh my gosh, it's doing everything. AVC. So this is setting up the AVC voltage, which might be way off too, which would explain lack of sensitivity. And we could see that by looking at the grids of the earlier tubes and seeing how negative they are. If they've gone way negative. Principally, interelectrode capacity. Because it's a triode, there's a fair bit of capacity inside the tube. Plate voltage 100. No, that's the low. High is 250. Grids -1, -2 volts in that area. Wow, amplification factor of 100. So that's pretty good. Plate current only 1 milliamp. Ooh, not much current. So let's just go around now that I know what the pins are and do the voltage tests again. And we'll try to convince ourselves I know where pin 1. So pin on this tube, pin 1, pin 2 are shorted. Wow, that's not going to help. Pin 1, pin 2. Okay, so pin 1 you see is a spare pin, and so in the radio they've used that as a connection point. Save them one spot on a terminal strip. So as confusing as it might look, this is pin 2. Come on, get on there. There's pin 2. Pin 2 is 0. Now, what is pin 2? Pin 2... Ooh, pin 2 is the grid. Pin 2, am I looking at the right thing? 6 SQ7, yes, definitely. Pin 2 is the grid. You can hear it. Oh, it's got a little negative voltage, just about right. Minus 1 volt. That's relative to the chassis. That may not be the best way to do this. Let's just see. Does this have a... what have they done with the cathode on this? So the cathode on this is straight to ground. So the negative voltage is actual bias voltage relative to the chassis. Chassis is ground. So that is the voltage on the grid relative to the cathode, minus a volt. Right on the settings here. So next one, right on, not the settings, the what this book is recommending. 3 and 4 are the two little plates of a diode, two diodes. So again, 1, 2, 3. Oh, wait a minute. Hold on. Hold the horses here. I think I'm making a mistake. 1 and 2 are connected together. Yeah, you see, the first time I read it, I got a 0. Then the second time, I got a little minus voltage. So I should have said, hey, how's that work? So that, yeah. So that's the grid. It's just showing 0. This is one of those little plates. I have to think about that for a while. -1. This is the other plate. The other plate is grounded. The other plate is straight to ground. The other plate is... No, that's not what this is showing. It's grounded through a resistor. It also heads off to a capacitor and heads back. I don't know what's going on there. Back to V3. I think that's the detector detecting the signal through that diode. And then right away in the same tube they start amplifying the detected signal. So I don't think we're doing too good here so far. Pin 3, pin 4. 1, 2, 3, 4. Pin 5. Pin 5 silences the radio somewhat. So it's some high impedance thing. Pin 5. Yeah, pin 5 is... Okay. Mistakes galore, man. I'm just making mistake after mistake. Pin 3 is the cathode, and that's why it's grounded like I see it. Pin 4 and pin 5 are the two little plates. Pin 4 and pin 5. So there's no B plus on those. I don't think there should be, but we'll have to look at the circuit diagram. Now we're getting to pin 6 where we should see a B plus. Pin 6. Pin 6 is that guy, and we see 86. Okay, well the tube will, work as low as 100. 86 sounds too low to me. We have defective capacitors here. These resistors may have gone high, R11, R12. Big capacitor there. Well, we need to get on the other side of these resistors here. So we follow back from the plate. Lots of wires coming off it. We should find something, working our way back, following the wires, trying to hunt. Now that's interesting because look, the B plus on V5 is connected via a wire through a capacitor over there. Should find a B plus of about over 200 on the other side of this capacitor. C35. Hey, the radio just went quiet. What's happening? The ground connection is crappy for my signal generator here. Okay, not to get confused by spurious equipment problems. So let's go off the plate of this tube. There we are. So I see a resistor, 22 with a yellow. What's that? 220K, I think. So that's probably that, R12. R12, 220K. So there we are. The other side of this, I think we see a high voltage. Well, not really high, 121. See, maybe it's low here already. And it's just getting lower as you go. That means this tube's not getting its full B plus either. Maybe. Maybe. Let's just carry on here. Other side of this capacitor, C35. Let's find that. There it is there. There's the capacitor. Right down there. Okay, on the plate side, we get the same 80 volts. On the other side, can't even see the other side here. Okay, I think that's it there. Yeah, down here. Yeah, over 200 volts. So that capacitor is sustaining a fairly good voltage. Now there's another capacitor coming off there heading to the grid. Well, that's interesting. Heading to the grid of the output tube. So let's check the grid voltage of the output tube. 6V6. Just to make sure. Because you can easily get a problem with the positive voltage on your output tube grid. That'll quiet the radio right down too. Positive. Maybe it wouldn't. I suppose in the extreme it'll quiet it down. 6V6. Grid is pin number 5. Grid is pin number 5. So we should come back and encounter that capacitor right there and a resistor. So come off the grid. Grid pin number 5. I gotta keep repeating these things or I'll forget them. So okay, 1, 2, 3, 4. This would be 5. Jeez. I think this one was 5. I don't see any voltage on it at all. Pin 4 has plate voltage on it or something like that. Pin 5. So it comes off to a resistor. What's the grid voltage of a 6V6 supposed to be? Wow. Let's see, 6V6. Grid number 1, -8, -12, -13, something like that. Wow. It's definitely pin number 5. We'll count them again and make sure we're on 5. So I can see the key on the tube. 1, 2, 3, 4, 5. 5. 5 has a 22K resistor coming off. That's pin number 5. R17. R17. 22K. So we're definitely on the right guy. No biasing. Now, is it biased because... Yeah, you see? The biasing is done differently here. Instead of biasing the grid, they biased the cathode using a cathode resistor. So if I measure the cathode, I'll effectively measure the grid voltage, because it's really the voltage between the two of them. What did I just say? Measure the cathode. Measure the cathode. 6V6, please. I should have like a little book with 3 pages of, you know, just the 5 or 10 most common tubes. 6V6. 8 is the cathode. So we'll probably find pin 8 to be 2-3 volts above ground. Pin 8. Is that what I said? Oh, jeez. Man, I gotta drink more coffee. 6V6. Right, pin 8. Duh. Let's just keep the book open this time. Smart move. Pin 8. Pin 8 has... Oh, sorry about that. I think this is pin 8. And you see 12 volts on it. And that's quite appropriate. That's the, and then there's this great big capacitor here. I don't know if you can see that. There's a big capacitor just above the thing here, bypass capacitor. So that's plenty good. And then we feed a signal into this output tube and it came out just beautiful too. So there's nothing wrong there. So I'm really on the wrong spot. So Just double checking everything though. Okay, so back to the tube in question. The one which appears to have low B+. And we're trying to sort out why that might be. So this resistor could be high, but I think the voltage on this side was a little low too. It's a great big honking capacitor here. What is that? C36. C30. A 100 microfarad. 2000 volt? 100 picofarad. Is that picofarad? Well, it's ceramic, so it must be picofarad. It looks like C36 twice in a row there. This makes more sense over here. This is C36, 4 microfarads electrolytic. So let's, was that this one that I took out already? Or, I can't remember which one. I took a capacitor like that out of some radio, I can't remember which one. So let's hunt it down and see what we got there. Okay, so that capacitor C36. So I should find it between these two resistors. So just beyond the R12 resistor, I should find a lead to this capacitor. I need a good pointer. Somebody, anybody, give me a pointer. A nice plastic thing to point with. I'll point with my voltmeter lead. How's that? Okay, so there's the resistor. It comes over here. There's another resistor, and then there's a wire, a red wire going up this way. Goes. Ah! What's staring me in the face? Look at. That's probably it. Right there. Darn hard to trace the wires up in there. Okay, so that wire. Here, let's use the camera. Let's use the camera. Okay, I'm going to turn off the auto zoom here. The autofocus. Force it to something like that, and away we go. Bearing in mind that this radio is operating, so I don't want to touch anything. And we know that elements of this camera, even though it looks plastic, are actually conductive. So let's see. Where are we going? So there, see the resistor right in the center of the screen, 22 with a yellow band. Follow the wire over to this terminal. Don't be fooled by that other resistor with the green band. It's not connected. And you see two wires coming off. A black one heading right back to another resistor right in the center of your screen. And you see this red wire. This is the one I want to trace. Don't be fooled by that other resistor. It is not connected. So there's the red wire. Let me just make sure I'm not going to get a shock here. Yeah, I'm okay. The red wire. And there it goes up the wall behind this capacitor, which we can now look at a big 4 written on it there, 4 microfarads. So this guy might be a bad actor. Yeah, let's get rid of him. Okay, shut off the radio. Do a couple tests here. You know, that's what's on the front of it. It's going up. It's always hard to explain readings like that. I've turned the radio off and this was going up. So some other capacitor must be bleeding into it. And it could well be these... Okay, so that's what's left in the power supply. 4 volts, not much. Well, and this guy's heading over it. I don't know. That certainly suggests the capacitor's not bad. Yeah, it's a little warm, you know. It's got a screwed in bracket. I can actually unscrew this. It's got a loose bracket now. Would that mean anything? Slot head screw. One of the greatest inventions in the world. I hate it though. There we go. Hang on to this little guy. That bracket should fall right off there now, I would think. Hey, wait a minute. This capacitor is connected differently. We've been fooled. Oh, I'm sorry, that's been out of focus all that time, hasn't it? Shame on me. Okay, so if we look now at the wire, we can see it actually comes off there and goes through a hole. And the other wire, yeah, what it blowing around here. But in the end, both wires connect to the same point. Anyway. Yeah, there they are. The two of them come up, they connect to the same point. Okay. I still think we should replace that thing, but I need a 4 microfarad capacitor. Now let's take a look at the situation here. That could be a 4 microfarad capacitor because that's the smallest they could afford to put in there. Something bigger would be preferable, but why put something bigger in there? It actually has a date on it, August 1950, I think is what it says. It might say 50 or 56 there. That's kind of interesting. So what this is doing then, this is taking the output from the... What is it doing? Well, you got me as to what this is doing. It seems to be... Maybe this is part of the feedback circuit here. Because it's right on the leads going to the speaker. It comes over right to the speaker leads, the voice coil leads, and also there is a signal traveling. Look at it very carefully now. That wire is grounded. So why they're showing it this way, I find this really annoying, because all they've done, they tied this capacitor to ground. But on the diagram here, they show it tied to a wire that goes to the speaker. I'm sure I'm seeing this correctly. So it's just grounded on the negative side. Let's see if that's what we see. So here's the capacitor, there's the green wire, and sure enough, it goes right to this grounding point here. Now, should we really replace this? I think what I'll do is I'll lift one wire off of it and we'll try to test it before I go so far as to actually replace it. And why? Yeah. So disconnect it there. trying to preserve the wire here, but I don't think I'm gonna. I didn't get anywhere there. So I was fooling around with some desoldering braid and a really nice solder sucker. And I was using a really nice solder sucker yesterday. The solder sucker won hands down. This is not a really good solder sucker, this one here. This is okay. They're all okay, but this one, when you fire it off, it goes shong and jumps around in that. Oh, that one I was using yesterday, when you fire it off, it goes. It's that airtight sort of, and it produces. It's a long tube, and it produces a lot of vacuum. I don't think I got a thing on that. Oh, maybe I did. Yeah, I think I did. You know, today I thought I would just plug in that tube. The radio would spring to life. I'd chuckle a bit and then get on with the alignment. But not the case here. I really want to get this radio working well. It deserves to be working well. Come on. I can't do it. I cannot do it. Here. Maybe this is... So what I'm trying to do is weaken the solder connection to the point where I can peel the wires off from, because the solder is cold jointed. Here. Really what I'm trying to do, but I don't think I've succeeded here. Oh, there it comes. So what I do is I heat it up and melt it, and then as it cools down, I'm wiggling the connection to try to make sure it doesn't freeze into a nice solid mass. If you do it right, you get a clumpy effect, and you can usually just manipulate the wires out at that point. A little touch of solder here is just going to pull right off. A little touch of soldering iron, rather. There it is. Okay, we got that off. So, first thing we'll do is we'll put the ohm meter on it. See how much of a resistor this thing is. Okay, so let's see. Might as well do it correctly. Here we go. I can't get into it here. And away you go. Whoops. There it goes. Nothing happening here. Wow, this one, you should see the meter whoosh, come down and come back up. Well, it's digital, so you know what I mean, though. I get the impression that this thing's got no capacity left in it. It's just open. I'm on 20 megohms. Let's go up to 200 megohms and see what we see there. First, I get the ground one on here. There we go. And now, nothing. Well, you know what? I mean, if you've got no signal getting through this, let's give it the stupid speaker test. Yeah. It's always fun to do the stupid speaker test. So what I'm going to do is I'm going to pass an audio signal through that capacitor to drive the speaker. And see what we get out of it. And to do that, I need some clip leads here. I need some wire, actually. Wait. 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 The radio's off. Speaker's out. It has wire. Let me borrow these wires. Smart move. I'll use that speaker. And yeah, that's a much smarter idea. Okay, so I'll take the speaker wires here. I connect one there. And let me plug in my cord here. Now this is a stupid test, and that is nothing calibrated about this whatsoever. This is what you call quick and dirty. So I'm just feeding an audio signal to the speaker through the capacitor. Here we go, through the capacitor. Well, did you hear any difference at all? It's slightly quieter. Now, let's just, since this is an uncalibrated test, let's calibrate it a little bit. I'll take a 0.1 capacitor. This is a tiny capacitor in comparison to the big one there. And we'll run it through that. Hear it? So, surprising to me, you can get that much signal through these capacitors. It's just surprising to me because I haven't done this kind of thing enough. Let's get an even bigger one. What's the biggest capacitor I've got here? Well, you know, we're not going to hear much difference. Okay, so there's that capacitor I took out of another radio. Maybe this one. 25 microfarads. September 1949. They were dating these things because they knew they weren't going to last forever. So as soon as I spot the clip lead, here it is. Okay, that's pretty loud. This is 25 microfarads, so it's a much larger capacity. The signal seems to go through this completely. I can't hear any loss. But this one I hear a very slight loss. You know what? I think we're proving that capacitor is good. I think that's what we're really concluding here. What kind of voltage is it sustaining? Oh, it's getting hit with lots of voltage. Ooh, yeah. I could take it out of the circuit and operate the radio, like it is right now, and see if that raises the B plus voltages. I can also put, let's do another test on the capacitor. Let's do a leakage test. Why not? Okay. So the way we'll do that is we'll actually put high voltage on it and read the leakage current going through it. You know, if the leakage current is really high, then this thing turns into a resistor, and of course signal gets through it. But we did test its resistance, and it looks open, so I have the feeling we're only going to prove that it's good. So I'm going to put this lead on here. Turn on my supply here. The other lead, I'm going to go up here, which is effectively the other side of the capacitor. Now come with me over here. See what my camera does, and I guess all cameras do this, when the light levels are low, it simply slows the frame rate down. to continue to achieve a good quality image. So here we are. That's the voltmeter and the current meter. What we're going to do is we're going to put voltage on this thing and watch and see if any current leaks through. We can see a momentary charge current flow in, but if we see a steady state current flowing through this thing, it's done. Okay, so now we're going to put on the voltage. Here we go. Okay, it's starting up, and we're watching this meter very carefully because it's a very small current we're looking for. Tiny charge current, I saw it. We've got 200 volts on that thing. Zero leakage current. Okay, everything we're doing is telling me that that capacitor is good. Really, it really, I mean, I've really lost the reason to replace it at this point. The last test would be to operate the set with this open, but you know, we just saw there's no leakage through it. So I think we've been chasing the wrong thing here. I think we just proved that this guy is actually good. We should leave him in there. What do you think? You think we should test this guy with that capacitor out of the circuit? First of all, the only thing that it can pass is a signal, an AC signal. So what? If it doesn't pass a signal, that's no problem. If it's doing something with DC, then you want to be a little more careful. For instance, shorting this out would not be a good move. But opening it, I think, is totally harmless on the radio. So let's do that. We'll leave this open. We'll turn on the radio. We'll see if the voltage down here has come up at all. But I'm pretty unhopeful about that. Okay, so quick safety check on the radio. Signal generator still connected. We're good to go. Started on voltage restriction. One of the reasons I start these on voltage restriction all the time, the main reason is in case there's an oversight, I've done something to introduce a short circuit. And I'll find it if I put it on current restriction, because my current restriction light bulb will come on and tell me loud and clear that things are not right. Now, we don't have a speaker connected. That's right. We don't have a speaker. Now I gotta stick my fingers into the live radio here. And this one here. I don't know if I like that popping sound very much. Kind of hints that there's a bit of DC there. There's the tone. So everything's exactly the same. How can we... So this is probably a feedback thing or something. It appears to have had no effect on the operation of the radio. Where's my voltmeter? Oh, right in front of me. Right in front of me. Put this on high voltage again. And we'll go in search of B+. In the way. The other side of the resistor is this terminal here. Look, it's 100 now. That was only reading 80 or something before. That's interesting. Let's connect the capacitor. It got fainter. I think it got fainter. Could be wishful thinking, but okay. So getting onto that spot again. You know what, I'm actually on the wrong side of that resistor, aren't I? I really should be over here. Okay, so there's the low 70. A slight increase in output could indicate this is a feedback circuit. Like exactly the same. Okay, so I think it's part of a feedback circuit. Feedback is used to reduce distortion. It's a very, very effective way of reducing distortion. And you might think, well, how the heck can that work? How can you feed back part of the signal that's made it wait through the radio and feed it back to the front and let it go through again? How does that actually reduce distortion? And I won't go into an explanation. I probably can't explain it. But it's one of the most important discoveries, if you like, in this kind of work to reduce, and all amplifiers, almost all of them use feedback to achieve low distortion. In fact, you can even have a sloppy radio, a sloppy circuit, and correct it with feedback. The price you pay is it reduces your output, which is just what's happening when we connect this. So I really think that's good. Let's put it back in the circuit. You know, another way of putting this is we just wasted a lot of time. But you know, you need to get some certainty by elimination of things that you think might be causing problems. So how am I ever going to get this in there? Man alive. This is some kind of... No, I gotta be more on the tip of my finger here. I don't know if I can get my hand in there. Ah. Right. I don't know what's going on here. Sometimes magnetic screwdrivers are a great help. Other times, man, they're a pain in the butt. Here, let's... Isn't this fiddly? You know what I'm going to do? I'm going to put the screw up through there. I'm going to do this backwards. I put the screw up through there and put the nut on the top. And that's just going to be that much easier to do. And stop the fiddling here. Some of you might have been mumbling that while you're watching me. I heard you. I heard you. Talking about hearing you, I'm going to do another Hangout on the Air next Tuesday night, 7 o'clock, with Scotty TR. And we're going to go a little further on that really cool 1920s radio, that 3-tube guy. Not so good there. How did that happen? Oh, and I guess when I was fiddling around with it, I bent the contact around. And that's back to normal. Okay, well that was a wild goose chase. I'm going to go refresh my coffee here.